So question 4 was a rates of reaction question, essentially. It's all about investigating the reaction between marble chips, which you really should know is calcium carbonate, and that's given to you. So if you don't know that carbonate is CO3 2- carbonate, I'd make a revision card on that. And calcium, of course, is in group 2, so it's calcium 2+. So calcium carbonate is that stuff, CaCO3. So the first question is asking you, what is the reaction between marble chips and hydrochloric acid? And you were given that it was hydrochloric acid as well. So you wouldn't get any marks just for writing those down. But you would need to work out what the products are. And you're told that the first product is the salt, calcium chloride. You should know from year 9, if not from your acids topic in year 10, that calcium carbonate reacts with acids, all metal carbonates and acids react to give you salt plus water plus carbon dioxide. So again, if you don't know that, that should be a revision card. So I'm going to put water there, I'm going to put carbon dioxide there. All you have to do to finish this question off is balance it. So that would be 1 mark, and balancing with the 2 there makes that balance. We've now got 2 chlorides and 2 hydrogens on both sides, and everything else is balanced, 2 marks. The next part of the question is about plotting a graph really carefully. I'd like to say that when you get your final exam paper next year, you will have to draw a graph, but the graph paper will be much better than what we got when we photocopy it. So I'm sorry that the graph paper was so terrible, but most of you coped pretty well, so well done. But we were fairly lenient when it came to plotting. And you got, it's out of 4, amazingly, 4 marks. And you got the first mark for having sensible scales. In other words, scales that increase evenly. So there's 1 or 2 people jumped straight from here to 0.3, 0.4, 0.5, and that's not a linear scale, so you lose a mark. But the scale has to fill up at least half the axes in both directions. That's your first mark. Your second mark is plotting. Your second and third marks are your plotting. And what they often do is they'll give you 1 point, which is usually clearly an anomaly. And this was a pretty hard graph to draw on dodgy graph paper. And you can see that I made a mistake there when I just did this a minute ago and put a spot in there. As long as you cross it out, make it clear that you didn't mean to do that, the examiner will be very tolerant of that in an exam. You get 2 marks for those. If you were off by some way, off by a small square or so, you would lose a mark. You can lose up to 2 marks for that. Okay, so where are we? That's 2 marks. So for the plotting, lots of you got 3 out of 4 for this. The final mark was to do a line of best fit. Now, here's one typical bad answer where a line of best fit was drawn as an attempt at a straight line through a curve, and of course that's not right. You have to draw some sort of curve, recognising, I think, that was an anomaly and therefore ignoring that anomaly. And the graph started right down at the origin, 0, 0, and you had to have plotted that point, by the way. And I would simply avoid this dot altogether when plotting my graph, or at least a smooth curve which brings it in. I'll get back to the rough one over here. If you'd have tried to draw a graph which drops down and then has come back up again to try to join all the dots together, you'd have lost a mark there. I think my pen's running out, but let's try the one. So your graph here wants to start at the origin. I'm going to do a bad job of this now. Well, that's a terrible job. But missing out that anomaly and not dropping away at the top, something like that would have got the mark, although I'm not very happy with this first bit, if I'm really honest, but never mind. You get the idea. You then, some of you missed out question C. Just don't think you read the question, you missed it, that there was 2 marks for drawing an additional line to show what you'd expect to happen if the reaction was done using smaller marble chips. If the marble chips are smaller, but that you've got the same mass, I think if you read the question again, you'll see that the initial reaction had 20 grams of marble chips. If we have 20 grams of marble chips that are smaller, they'd have a higher surface area, so the reaction would be faster, and therefore the graph steeper. So your line A that you had to draw had to be a steeper curve, and so would have a steep bit at the start, because the steepness of a graph is related to its rate of reaction. The steeper it is, the faster it's reacting. And the fact you had the same mass of marble chips and the same amount of acid meant that you'd end up with the same amount of gas produced in the end. So you got a mark for drawing a graph that was steeper, that was labelled A, and you got a graph for finishing it in the right place, finishing it in the same overall volume there. Okay, so if you drew another straight line, you probably wouldn't have got the mark there. You had to then explain how and why the rate of reaction changes during the reaction. And I would say this was answered relatively badly, and it's something that I would definitely get better at. It's something you can really work on to improve. So let's look back at this graph. Now, at the start, the reaction is going very quickly, the gradient is very steep, and over time, the reaction slows down, and we can see that because the gradient shallows, and eventually the reaction stops, and you can see that because it's now a horizontal graph. The reaction is not producing any more gas at all. So you have to be clear to start with that that the reaction slows down. So this is the fourth mark, if you like, in this section. But the reaction slows down during the course of the reaction. Starts fast and slows down. Why is it doing that? Why is it slowing down? And the real reason is, and some of you talked about calcium carbonate changing here, but really it's to do with the fact that the acid is being used up. So during the course of the reaction, the acid, you did get the mark if you said calcium carbonate or marble chips, but the acid is being used up during the course of the reaction. Now this affects one of those important factors that affect rate of reaction, which is that the concentration, if you've used up some of the acid, the concentration of the acid will go down, decrease, okay? So if the acid's being used up, there's less of it in the same volume, so the concentration's going down. And you know, don't you, that the explanation for lower concentration reducing rate of reaction is because there's a lower frequency of collisions. It's collisions between the reacting particles, and the faster they go, the faster the reaction. So if you've got less of the particles in there, they're going to bump into each other less frequently. And you had to use those two words. You can say collisions per second if you like, but frequency of collisions is easy to remember. And the explanations for why higher surface area causes a faster rate, why increasing concentration, increasing temperature, and adding a catalyst to increase rate of reaction is really important going into next year. The next one here, another student investigated the rate by looking at change in mass. So this is when you put a reaction on a balance. There's the thing, and you'd have maybe a conical flask on top, usually with a bit of cotton wool there to stop anything splashing out. But you do the reaction on a balance like that, and the gas will escape through the cotton wool without any splashes coming out as well. And you'll see the mass decrease a little bit over time. Okay, the mass decreases from, in this case, 152 grams, just down to just above 150 grams. But you have to work out the mean rate of reaction. In other words, the rate in grams per second, it says that at the bottom there, during the course of this entire reaction. Right? So now the mass lost during the reaction, it started at 152.5. There's 152.5 grams, and the mass finished at 150.3 grams, and that's a mass change of 2.2 grams. So if we're going to work out the rate in grams per second, we need to know the number of grams that have been lost. So just do the starting mass, take away wherever that line is, the final mass. Okay, so 2.2 grams, and that's 1 mark. The time taken for it to use that loads of you said 300, but if you look really closely at the graph stops at 270 seconds, which is there. There's no further reaction taking place after that point. So well done if you spotted that. Not many people got that. It allowed if you gave 265, but you have to realise the reaction stopped after 270 seconds. You get a mark for that. And then the rate is simply 2.2 grams per second, so divided by 270, and you get a mark for writing down the answer to that, which was 0.008148. And then finally you get a mark again, this is twice in this particular paper that you get a mark for writing to 3 sig figs, which was 0.00815. Okay? If you gave 265 or 300 seconds there, you could get errors carried forward, or if you got a slightly outmassed, we could get errors carried forward there. So you might have got some marks, even if you got one thing wrong. A trickier skill, and some of you forgot how to do this, is how do you work out the rate at a particular time point, and the particular time point you're told is 150 seconds. Now, a moment ago on the previous graph, I said to you that the steepness of a graph is related directly to its steepness at that point, and the way you measure the steepness of a graph at a particular point is to draw a tangent at that point. Now, stupidly, I don't have a graph, a ruler to hand. Maybe I do. I've got a ruler. So you draw a tangent at that time point there, making sure that your tangent is a fair reflection of the steepness. So you could look to see whether the graph is kind of that matches the steepness of your curve. Take your time getting it right. If you get it wrong, you don't get the mark. You draw a nice big tangent, usually all the way to the axis, I find is the best way to do it. And you get a mark for drawing the tangent. Then you have to work out the gradient of that tangent by doing, as many of you have learnt in math, the rise over run. So this is about 151 point, roughly 8 and 280 seconds or something. You got a mark for drawing a tangent in the right place, and you got a mark for showing that you understand you do rise over run, and you got a mark for getting a value for the gradient which was somewhere between 0.0065 and 0.0075. Okay, and that's what you're after for your gradient there. So it's the rise over run, in other words, the mass change for that tangent divided by the time change for that gradient. And then finally you had to give your answer in standard form, and so it was 7.5 times 10 to the minus 3, or 6.5, or 7 times 10 to the minus 3, depending on what value you got there. And that's the end of question 4.